Hi, this is John, and this video is going to be talking about a modified version of a digital safe application that is found in Programmable Microcontrollers with applications using the MSP430 Launchpad with CSS and Grace by Cem Unsalan and H. Deniz Gurhan. Now, two modifications I made, two big ones. The first modification is the voltage regulation. Now what that is when you're running the Launchpad, the chip I'm using is the 2553. When you're running the chip off of the Launchpad, it's getting its voltage from the USB port. It's getting 3.6 volts from the USB port that it's plugged into. Now when you put it on the proto board, it needs to get voltage from somewhere. And mine is getting it from a 9-volt battery. Now I'm stepping down this voltage from the 9-volt battery using the LM317, which is an adjustable voltage regulator. That means I can adjust the voltage up or down. It isn't fixed. And I adjust that using this potentiometer. And I adjust the 9 volts down to 3.3 volts. 3.3 volts is the minimum needed to run at full 16 megahertz. So I figure that's pretty much good enough. So to give it a little demo, I have the 9 volt going down this rail. Here's the switch. I'm going to go ahead and flip it. So you get about 7.8 volts. And after the voltage regulation, do the adjustment with the potentiometer, we're going to go ahead and get 3.32 volts, which is good enough for me. Now, the second modification that I made is I used a reset push button. Whenever you push the button, the programming on the chip resets. Now, whether or not you want to add a push button reset, what you need to do is whatever voltage you're giving the chip, you also need to feed that voltage through a 47 kilo ohm resistor into the reset pin of the chip, or else the chip just doesn't work. And so going from the Launchpad to the proto board, that's a must, no matter what voltage regulation or what you do. You need to have the voltage going through a 47 kilo ohm resistor to the pin of the reset. Now, talking about the digital safe application, we have some LEDs that indicate what state that we're in. We have some control push buttons that control whatever we're going to do. This one is the enter new passcode. This push button is the lockdown the passcode. This push button is enter a passcode. And this one is test the passcode. And where the passcode is being entered into 4 switches. I know this is 8, but I'm only using these top 4 switches. So let's go ahead and run through an iteration of this digital safe. So we got this digital safe. We brought it home. We're going to enter a new passcode for the first time. All the LEDs turn on, the red, the green, the yellow. And we're going to enter a new passcode. Something simple. I'm going to lock that passcode down. The red LED turns on, letting me know it's locked down. I'm going to close the safe, go about my business, come back. Want to get into whatever I put in there, I'm going to enter the passcode. The yellow LED comes on, telling me to enter the passcode. So I'm going to enter a passcode, then I'm going to test it. Bam, red LED, that means the passcode was incorrect. So I'm going to hit the enter passcode button. Yellow LED lights on telling me to enter the passcode, test the passcode. The green LED comes on telling me that everything's good to go. Now the way that the software is written, every time you enter the correct passcode, you have to enter a new passcode. It doesn't have to be a different passcode, just a new one. So you hit the enter new passcode, all the LEDs turn on, and you go through the whole process all over again. Now, as I said before, this is the modified version of the digital safe application. If you have any questions, go ahead and leave them in the comments and I'll answer them as best I can. Have a good one.